Hello, Precalculus, and welcome to 4.3. This is labeled the right triangle trig, which you're going to use to finish out the unit circle with your 30, 60, 90s, because now you'll know the 30 and the 60-degree angles, where before you've already learned the 45. So we're finishing up the unit circle is what we're doing here, and making sure you know how to get to all those ratios. Okay, make sure you got your notes out. You'll need your calculator, and let's go. Okay, right triangles to evaluate trig functions. We're going to work on the values of the 30, 60, 45, and 60. These you already know. We're going to use co-functions or complements and right triangle trig to solve applied problems. So we're going to have a few story problems in here. All right, let's see if you remember. So sine is what over what? You should say opposite over hypotenuse. Okay, pause and fill in the rest. All right. So we did opposite over hypotenuse, adjacent over hypotenuse, opposite over adjacent, or SOHCAHTOA is what you would have learned in geometry. Remember that old thing? It never goes away. May have learned something else about hippies, but hopefully you learned at least SOHCAHTOA. All right, here we go. Now, I want to find all the trig functions. I'm going to give you the tangent is 3/4. I know tangent is opposite over adjacent. So on your triangle, the first thing you do is you mark the angle you are using. You make sure it's right. Opposite over adjacent, so opposite is 3, adjacent is 4. Your next step is to calculate C. So we're going to do 3 squared plus 4 squared equals C, which is 9, or C squared, I'm sorry. 9 plus 16 equals C squared. 25 equals C squared. So C is equal to 5. We don't do plus or minus because distance cannot be negative. So this is 5. Now all you do is you write down all of your trig functions. So you know the sine of theta is equal to opposite over hypotenuse. So you're going to say 3/5. The cosine is adjacent over hypotenuse. So that is 4/5. Your tan was given to you. By the way, see how I just made that a capital letter or a capital T? You probably shouldn't do that. Generally, when it's a capital T, a capital C, or a capital S, it means it's in the first quadrant is what that talks about. If they're lowercase, it can be anywhere, just in case you run into it. Okay, remember your opposites. Cosecant of theta, invert it. Secant, I'm going to run out of room, of theta is equal to 4/5. And then your cotan of theta is equal to 4/3. All right, pause and do yours. All right, I hope you did well. Your first step should have been to label your theta and then put in your angles. We know this is opposite over hypotenuse, so you did opposite by 13. Use your Pythagorean theorem to solve for the other side, which gave you 12, then plug them in. So you got sine, cosine, tangent, opposite over hypotenuse, adjacent over hypotenuse, opposite over adjacent, then cosecant. Remember, everybody's got to have a companion. That's why you know these go together, right? Cosecant, we have a cosine with a secant, so here's our here's our and then tan is co. And then 12 over 5. I hope you did a great job. I think these are kind of fun. All right, now we're going to use these to do our sine and cosine and tangent of 30, 60, 90, and 45. Well, 45 we've already talked about. We said that's 1 square root of 2, which we know. And then when we do our things, we have to divide. And we want, in our unit circle, this to be 1. But right now we're not, we could. But make life a little bit easier. Let's do that. So we want this here to be 1. So in order to get it to 1, I have to divide everybody by the square root of 2. I am not going to rationalize at this moment. Okay, this here showing you how the 30, 60, 90 comes about. Okay, when you first do an equilateral triangle, remember everything's the same. So that means all angles are 60 degrees. Okay, now you know if you drop your perpendicular from geometry, you form your 90, but since it's perpendicular and these two are identical, that cuts this angle in half, making this the 30. Well, if this side was originally 2, half of this side is 1, and then using your Pythagorean theorem, you get the square root of 3. So you could actually calculate a 30, 60, 90 without any difficulties. Now when we look at this, again, we want the hypotenuse to be 1, so we're going to divide by 2, 2, and 2. So now we got 1 here and here for my hypotenuse. So now we are in the unit circle. So we know sine is y. So when you're looking at your 45, you're looking at your y. And so the sine of 45 is 1 over square root of 2, or rationalize union denominator, square root of 2 over 2, which is identical for the cosine. Then when you look at a tangent, something divided by itself is 1. Now let's go over here. I need you to fill these in, because the sine of theta is a reciprocal of the cosecant of theta. Cosine of theta is reciprocal of the secant of theta, and tan is the reciprocal of the cotan of theta. All right, so if I have to invert this, we knew it was 1 over square root of 2 to start with, so now it's just the square root of 2. We know that sine and cosine are the same, so cosecant and secant are also the same. And cotan is just a reciprocal, which is also going to give you 1. All right, 45s are done. We have finished this triangle. So now let's move on to our 30, 60, 90. So we're talking about 30 degrees, so we're talking about this angle right here. So this angle right here, I know opposite is the sine, so we're here. So the sine of 30 is 1/2. Well, that means the cosecant of 30 is 2. All right, now let's go here. The cosine of 30, adjacent over hypotenuse. So we got the square root of 3 over 2, which means the secant is 2 over the square root of 3. Rationalized is 2 square roots of 3 over 3. Okay, let's do tan. Tan is 1/2 divided by the square root of 3 over 2, which is going to give you 1 over the square root of 3. Rationalized, square root of 3 over 3. And the same over here. So now we just have the square root of 3. All right, now let's look what happens when we go the other direction. We need a new color here. Let's go with red. So now we're looking at sine of 60. Well, the sine of 30 was 1/2, and the cosine was the square root of 3 over 2. But look, when we flip angles, we flip who goes where. So now the sine is the opposite, which is the square root of 3 over 2. All right, the cosine, so the cosine's value here went here. So the sine, the cosine is going to be adjacent, which is 1/2, which was the sine of 30. See, 30 and 60 add to 90? And this here is helpful because our 90 degrees go hand in hand. And then again, square root of 3 over 2 divided by 1 over 2 is the square root of 3. Flip them for over here. So now we have 2 over the square root of 3, which equals 2 square roots of 3 over 3. Here we have 1/2, which is 2. Okay, I have to put the cotan in. Here we have, oh, it went away. That's supposed to be 1 there. Here we have the square root of 3. So we get 1 over the square root of 3, which is the square root of 3 over 3. Okay, remember these are just 30, 60, 90s because you're going to have to fill in your triangles. Okay, 2 positive angles are complements if their sum is 90. That's why our 30 and our 60 work so well together. They're complements of each other. All right, so their 90 degrees, or pi over 2 is what they add to. And we know if I have the function of theta, so if the function of 30 is equal to g, the second function, the cosine, of 90 minus 30, is what this is saying. So when you go down here, it is telling you that the sine is the same as the cosine with 90 minus the angle. Tangent is the same as cotangent when you take 90 minus the angle. And secant is the same as cosecant with 90 minus the angle. Same is true with cosine. It's the same as sine with 90 minus the angle. And we just continue this down. So we can get to the exact same place because they're complementary angles. Here's an example. I want to find the cofunction. So I know the sine, its cofunction is cosine. So 46 degrees is the same as the cosine of 90 minus 46, or the cosine of 44. Or the cotangent of pi over 2 is equal to the tangent of 90, because 90 is pi over 2, minus pi over 12, which gives us well, we changed this to a common denominator, right? So 6 pi minus 1 is 5 pi over 12. Okay, pause and try yours. All right, I hope you did a good job. The cofunction of sine is cosine. So the cofunction is the cosine of 90 minus the angle, which was 72. So the sine of 72 is equal to the cosine of 18. Cosecant of pi over 3, its cofunction is secant. We subtract pi over 2, getting a common denominator, and we have secant of pi over 6. So the cosecant of pi over 3 is equal to the secant of pi over 6. Here we go. I hope you remember angle of elevation and depression. It says, where would the angle of elevation be from the point of view of the car? So you're here, where's the angle of elevation? I'm hoping you remember it's right here. This is a geometry class, right? So if this is parallel to this one, or the road, and you draw your transversal, alternate interior angles are the same. Remember those words? So this here is the angle of elevation. Well, it says angle of depression here, but remember the angle of elevation going up is the same as angle of depression going down. These two are also identical. All right, now, siting the top of a building, the surveyor measured the angle of elevation to be 22 degrees. So we have a surveyor. So he is standing is what this is. So here's my little guy. He's standing looking through this little thing here. It's on a tripod generally. He's looking at the top of my building. All right, hope you got your thing drawn. The angle of elevation, so what he sees actually, here's my parallel line, right here is 22 degrees. The transit is 5 feet above the ground. Well, the transit's the little thing he looks on. So whatever this height is, I got to add 5 to it. That's how high he is. And 300 feet from the building. So from here to here, from where I'm looking to the building is 300 feet. Find the angle's height, or building's height, I'm sorry. So I need to find x and then add 5 to it. Well, this here would be opposite over adjacent. So since this is opposite and this is adjacent, I know I need to use the tan function. So we'll do the tan of 22 degrees is equal to x over 300. Solve this. So now we're just getting a common denominator. Multiply both, multiply by 300, top and bottom, whoops. And then that goes away. This equals x. When you type that into your calculator, you're going to get 121.21. The problem is, this is from the transit up. So I got to add the height of the transit to that. So we got to add 5 to this. So we get 126.21 and feet. If you rounded to 126, I would absolutely take that. Hey, your turn. Pause and do yours. This one was very similar to the other one. Here's our angle of 24 degrees. This is opposite and this is adjacent, so we know we're using tangent. We did the tan of 24, a over 750, solved, and you should have got 334 yards. If you are not getting these right answers, make sure you check the radian and degree mode on your calculator. Okay, find the value of the angle. So if I'm giving you 21 over 25, and I want to know this angle, to do this, I have to use the inverse tan on your calculator. So you have a button that says tan to the negative 1. Literally, all you do is type in tan to the negative 1 of 21 over 25, and this is going to give you the degree measure of that angle. I think I got 40. Let me pause. So that's it. It's making sure you know what you're finding. So when you use inverse tan, you are finding angles. You are not finding distances. All right, pause and do yours. All right, this time you were given two different sides. You were given the opposite and the hypotenuse. So you should have done 3 over 7. Now remember, in order to find an angle, you do the inverse of the operation. So the inverse of this trig function is inverse sine of 3/7 equals a. Plug that in, you should have got 25.38 degrees. Okay, make sure you're checking degree and radian mode on your calculator. And this here is a unit circle. It is here for you to practice. You need to put the degree measure here. So like this is 0 degrees. It can either be 0 pi or 2 pi. Either one is correct. This point is actually 1, 0. So, all right, there we go. And you're supposed to fill this in all the way around. So the next one, this is 30 degrees. So what is that as a radian? And you should say, hey, that's pi over 6. That's how I get to 30 degrees. And when you do 30 degrees, you're dropping down this line. Whoops, maybe. All right, remember this is 30. If you don't remember exactly, you do remember 1, 2, square root of 3. Has to be a unit circle, so you have to divide by 2. So now your 30 degree, your x is the square root of 3 over 2, or your cosine value, and your y is 1/2, which is your sine value. So remember, this is sine of 30, and this is cosine of 30. You need to fill all the way around. I want you to be able to do it, because you have to be able to do it without any calculators or without any help. If you remember your 30, 60, 90, and your 45, it's just patterns all the way around. So give that a shot and practice it more than once.